Okay, I think we will jump right in and get us back on track a little bit more here. So my name's Chris Hill. I am president of Tsunami ARVR. We are a relatively new company that is a roll-up of a number of different acquisitions that we've been making, focused purely on enterprise applications and applying augmented and virtual reality. So I'll touch on this a bit. My history was 17 years with AT&T, running their solutions group and their IoT business. And what got me excited about moving into this space was this looks and feels a lot like mobility was 15 years ago as we were looking at mobilizing business processes. Now we're looking at virtualizing and augmenting them. So I'll spend a few minutes on where I see the intersection of IoT and AR and VR. Also wanted to just give a few stats around what we're seeing now in some of the studies in worker training and productivity in using immersive technologies like virtual and augmented reality. And then show a quick video on how it's being applied, both a little futuristic, but also in process and applications that are being built today, and where this will be going. And then last but not least, on where we've been working with clients and talking through where do you begin in this space, because it is still early days. So I touched on this briefly here. The work that we've been doing heretofore has been all enterprise-centric, and we've been starting to get a lot of good experience in understanding some of the complexities of tying in these virtual and augmented realities technologies with companies. So some of our big customers like United Technologies, where we're working with Otis Elevator or with Boeing and their wire harness facility. We'll talk through some of the applications and how we're seeing those being applied there. Companies based in LA, Irvine and San Diego, and we're just over 270 employees at this point. So one of the things that has been happening, and as technology waves have been coming upon us, is the frequency to which we're moving between the physical and the digital world. So as we look back in the mainframe and PC days, you would have your interactions in the digital world, and then you'd go interact in the physical world. As you move forward with your smartphones, and this is probably even more so if you have kids, their frequency is very high as they're moving between their physical and digital worlds. And now as we look at augmented reality, we're looking at this being an ultra-high frequency event, and where you are looking at the physical and digital world at the same time and interacting with those. And how does that take place, and what information needs to be provided, and also what technologies get displaced along the way. That's one of the big ROI drivers that we're seeing as we go out and start looking at field service solutions and field tech solutions is, do you really need the tablet as we move forward? Do you need that laptop in the field? Or is the communication embedded in the glass, or is your smartphone your connectivity hub? So there'll be displacements along the way. It is without a doubt, in my mind, in the next 10 to 15 years, every service technician will have some type of augmented reality visor, headset, glass, providing work instructions, remote mentorship, and we'll show that and some of the results we're seeing in the early days. So this is some really interesting work and findings with one of our clients, a Swedish energy company. On the far left there is, we've been working with them now a little over 2 years. This study just got completed. The service tech is changing out a shank adapter, and I didn't know what those were at first, but it's a part within the pneumatic drilling rig. And their traditional classic training, it took 2 hours for the tech to go out and go perform that service work on changing out and understanding how to do the shank adapter. They've gotten that down to now to 15 to 20 minutes by providing those step-by-step work instructions in the glass. This is with HoloLens, and being able to do that without having to go back and forth between a manual or a laptop or some other medium. So, dramatic cost savings there. They factor that at 92% cost savings in their workers per hour rate of 32 euros per hour in terms of the technician training time. Similarly, as we've seen more complex training, we did a virtual reality simulator in oil rig operations, and we've seen the training time drop from 2 years to get an oil rig operator fully up to speed to now 9 months. So these are the kinds of things, while they're not specific use cases today on smart buildings, these are going to be applied most certainly as every type of training is going to be affected and I believe moved in some type of immersive format just because of how fast the body is able to render and understand the material. The other thing to be thinking about is creating the digital twin of any number of products, machines, processes that you have out there. Today, there's a lot of complex CAD models that are out there today. It will not just be taking these high polygon count CAD models and dumbing them down so they can operate in a laptop or a smartphone or on a HoloLens device. That may be useful in some applications, but you need to be thinking about what you're going to be doing and what you're going to be working on so that you can get to that high level of detail only when and where you need it, because it's not realistic to be able to, one, create a bunch of 3D objects off CAD files. Those are very expensive processes and projects that you undergo. It may make sense for certain things like a Boeing jet engine where we've done that. But for more simple things like working with a large real estate company, InSinkerator, we don't need to go to get heavy-duty CAD files. We just need to be able to look at it and understand which model and which object that is and then pull up the appropriate manuals. And that's a real use case, one that we're working on out in California today. And so you'll see a number of different technologies that are going to get applied to augmented reality to be able to understand what the glass is looking at. And that ranges from physical object recognition to actually having the ability to scan, or a physical scanner that's tied into the solution so that you can scan it and understand what you're looking at, to these dense point clouds, which are a lot less heavy in terms of the application size and file, to the far right, which is importing and working with the CAD software. So I bring that up there. It's just something you're going to need to be thinking about and working with your various partners and ecosystems on what is the right 3D models you'll need in facility maintenance to deploy, or with your ecosystem partners and things that we'll be working with them on. So as we look at facility maintenance and operations, we have fire suppression systems there, to HVAC, to hot water systems. All of this is being connected, as we've been discussing here, and it's been happening over a number of years. That sensor data is coming off and now applying analytics to that, both in real time but also predictively. So one of the other applications that we've been working on that is similar is with the U.S. Air Force. They've got an issue with keeping aircraft, their uptime. 63% of the time is the availability of the U.S. Air Force aircraft. And how do they move that number higher? One of the issues is the technicians. It takes 10 years to get proficient in working on the jet aircraft, and they have a lot of turnover, and techs are leaving before they reach 10 years. So how do you take that and compress that time through immersive technologies that allow them to be in a remote mentor that can see what they're doing, but also provide those work instructions so that the workers are actually now much more proficient. And if you have ever tried one, who's tried a HoloLens and gone through like a work step instruction? You sort of feel like you slept at a Holiday Inn Express. You wake up, you feel like you can do it. It's literally, I'm changing out an actuator on a F-15 wing, 38 steps. It's all drawn out for me and talking me through exactly how I do that. Then you tie in predictive analytics. So the other piece is when you're opening these big machines up and you're spending the time and effort to go fix or replace a broken part, the ability to then, through predictive analytics, to understand that in 3 months from now, well, this compressor is likely to go, so while I've got everything torn apart, it's going to be cheaper for me to go ahead and replace that compressor now, and instead of having to tear it down again before when it breaks. And so that's a key piece to tie into the solutions as we look at this, and where I truly see this intersection of IoT and augmented reality. And then how are you going to visualize it? And it's a little hard to see in this picture, but in the far right would be more of a safety concern application where they're using an iPad and it's highlighting, here's a high voltage system, beware, as well as high temperature pipes that are going through. So things just with some simple safety application there to be able to allow a tech to understand, be careful, this is a high voltage area, to then providing in the lower right area just visualization of the work instructions and what they need to go do. And the hardware is continuing to progress. So I mentioned HoloLens a lot. That's one we like to work with quite a bit in these maintenance and repair operations. But there's a number of ones that are becoming ruggedized, intrinsically safe, can fit with hard hats. And so that will continue to progress. But certainly good enough now to start working on pilots and proof of concepts and thinking through how this is going to be applied. So let me do a quick little video here. Hopefully this plays. Correct. We're hardware uh-oh, we not have internet connection? Yes, I need to couldn't pull down this YouTube video, so I was trying to go out. Any hope on that? Back, we're just recording? Guess no chance. All right. Well, it was a great video. Yeah, exactly. So if you have a chance, go on YouTube, the ThyssenKrupp elevator video there with HoloLens. And they've actually done a lot of work in applying the smart elevator. So it comes in and has a connection. They provide their work instructions they have 20,000 elevator techs around the world that they are outfitting or in the process of outfitting with HoloLens, augmented reality glass, and it's another little piece of technology that the technicians are carrying with them. From the beginning, when they get their work orders and they're sitting at their desk, it works through a set of instructions on what they need to be doing, providing the right manuals, and then being able to take that out on the work site and then connecting with the elevator on site. The elevator's providing diagnostic data back into the visor that says, here's my problem, this is what needs to be fixed. He knew that from the work order and then is able to have the step-by-step instructions to work through, as well as you can see how the remote mentor is being applied. It's a slide above. Slide above. Right there. Being brought in to assist. And obviously this requires network connectivity to be able to provide that kind of capability. But it also gives you the ability for storing this information for forensics, should you need to pull up a work log to see what was actually done, was it done correctly? And so you have all of that data if you choose to store it and keep it and understand what went on. Yes.
Yes. No, I don't know.
Okay, all right, that's fine.
Yes.
I think I explained it now. So, so as we look at this, it's across a number of areas, and we're starting work, and there'll be obviously a lot more companies that are focused in working with the industrial internet in this ecosystem to be able to provide virtual and augmented reality applications. I see virtual reality in the areas being utilized for training, not so much in the field. As we look into field use cases, augmented reality will be the key technology that would be deployed and supported. And the worker productivity gains that we're seeing are significant. So to give you one more example, working with Boeing and their wire harness facility in Mesa, Arizona, this is a huge facility where they're taking thousands of wires and they're jamming them into the harnesses that these assemblies then go into the wings or the bellies of the aircraft. And so the process before applying an augmented reality solution was the technician would go to a series of bins, pull out the wires they needed in the various harnesses, go back to their table, and then look at their laptop to say, okay, these are the parts that need to go together. And with that was just inherent issues with error rates and forgetting what they looked at, snapping in the wrong wire. Well, we applied a very simple, they applied a very simple Google Glass application that then is able to read barcodes in the bins, so they know which bins to pull the wire harnesses from and which wires. And then when they get back to their table, they don't need to look at the laptop anymore. It's physically highlighting the blue wire going into this connection in the harness. So they've seen a 25% increase in productivity and taken their defect rate to 0. So these are just some of the early applications that are starting to go out there, and why I truly believe this is going to be the next big wave in terms of technology that's going to affect pretty much every industry, but certainly those that have heavy equipment, industrial equipment, complex machines and processes. And I think we've been talking about the ability to, at least from my days in the wireless world and as a carrier, to be able to remote in and doing two-way video conferencing. I believe we're finally there in terms of the right tool that would allow a remote mentor to go look in and help a junior technician work through an issue that they're seeing in the field. That is here. And then there will be a lot of hardware solutions that will come out for the right tool for the right job. So, where would you begin? Where would you look at this? These are some of the areas, the high-value areas, your high-value assets and facilities and buildings. These are ones where we're working with ecosystem partners now, whether it be the Siemens or the GEs of the world and others, Otis and ThyssenKrupp. So those are some of the areas that we're initially looking at. Audit and inspection is another big area in facilities, the ability to go through and with the HoloLens detect things that are where they should be or where they shouldn't be, and providing that error or verification that as they go through audit and inspection, and then also having the backup video files of any areas that they want to record and look at for future reference. The next step is starting to lay out the architecture, just as the work has been done and connecting all of these devices in IoT. It's also done on what do we want to bring out to the all the way to the edge, to these augmented reality glasses or virtual reality solutions, and the work that's being done there. Are you working with predictive analytics software? If so, who are they? And starting to tie that into the solution, thinking that out. Are there specific hardware requirements? So I work with Exxon, and we're getting out into the field. We have to have intrinsically safe. There's not an intrinsically safe device out yet. So, but there will be the first ones coming out later this year. So you have to understand that, but it doesn't stop you from starting to pilot this, starting to get understanding within an organization as to how this technology is going to start to be deployed.
Could you define intrinsically safe in context here?
Yes. So this is devices that I forgot the exact rating that they have to have, but no spark proof. So they're in an area that where they would not be able to generate or cause a spark that would cause an explosion. That's my lay term. I'm sure there's much more technically accurate descriptions of intrinsically safe, but that's what's required when you're in those.
So there's no other aspect of hard hat or visual acuity and visual range of vision or other things like that?
Well, they may have those requirements as well, but intrinsically safe, no. That just simply speaks to the electrical. But hard hat is another big area there where HoloLens obviously isn't going to fit the bill if you have to have a hard hat on. RealWear is a company that we're working with here that has a ruggedized snap-on to your hard hat. And so you'll see the device types proliferate, I think, tremendously over the next few years to start to address all these various use cases.
You mentioned two brands. What are the top 3 or 4 that you could name also?
In augmented reality, HoloLens is by far and away the leader in this space and being used, Microsoft HoloLens. RealWear is one that we're just starting to do some work with. That's starting to get traction. There's 2 others here that they're escaping my. It's Austrian or German, and I'm R7 is the model number, but
Osterhut Design Group.
Yes, exactly. Yep, that's another one that we've designed applications for that we like quite a bit, especially with field of view.
V9, not the V7.
Okay, all right, thank you. And then there's one other, the full helmet size that we're doing, that we did a little bit of that, but the issue we found in the field there is it just gets too hot. You have to be in a very temperature-controlled setting to be able to walk around and have that full headset on more than a few hours. Some of the other things we're starting to see, low light is an issue there, battery life. There's all those things we're starting to see in the early days of the application, but today, you can get 3 to 4 hours out of a session on HoloLens. And most of the things that we're doing now is piloting and proof of concept so we can start to understand what are all the things we need to think about when these go to operational deployments. And we're starting to get some interesting metrics as we look at for the, building these business cases from some of the worker productivity aspects that I stated, reduced downtime and first call resolution. There should be no reason that the Comcast rep has to come to my house 5 times to fix something. This should be something that should be able to be done even with a junior tech to be able to get that first call done and obviously drive down costs by not having to do further truck rolls. Obviously, with reduced downtime, you've got higher customer satisfaction, and that in turn can help drive revenue and improve your SLAs, which can be a competitive advantage as well. And then last but not least, the areas that we're sitting at today is dividing those user groups, which are those ones that are ready to test out and start to look at utilizing this technology and seeing which technology can be displaced.
Quick question. So what percentage of use cases that you've seen in the field need real-time two-way communications?
We've steered clear of most of those, and so the ones we're working on, we don't need real time, but it's going to be needed when we start to get into, as we look at the predictive analytics, and they're actually in there, and if they haven't gotten that information ahead of time on, what else to fix, we're going to be able to provide that. So right now, we're looking at a couple different solutions where we'd be able to have a small pack. It would give the cellular connectivity while in the field, and Bluetooth back up into the HoloLens device. But up to this point, it's all been in wireless LAN, either manufacturing, warehouse facilities where we've got fairly good bandwidth.
But there are some places that are Faraday cage.
I'm sorry?
There are places that are Faraday cage, it just knocks everything.
Yes, correct.
So you have a memory pack that you go with it, so you download everything?
Correct, yes. And it has a fair amount of memory. You're not going to be able to pull, if you go off your work order that's already synced on there to something else, then you may not have that right.
No, I mean something that has all those documents going to be with it.
Well, maybe, right? It just depends on how complex the machine is that they're working on, whether you can actually have all that, right? If I'm going to go work on a locomotive, I'm likely not to have all of the work manuals that are with me, right? It's once again determining what information I need at that time, and that's also one of the pieces where I'm looking at the 3D objects going, allowing the application to narrow down to a fine point as to when I need that granular detail versus having good enough recognition to be able to hone in. And those are some of the things we're working on.
You gave the use case of pulling data for analytics off the device and backhauling it somewhere. You didn't earlier you mentioned actually talking live to human supervisors.
Correct.
So where does that play? And that's also real-time communication.
Well, so a lot of the predictive analytics can be done in advance. So you have a work order that's, in the case of the Air Force scenarios that they provided to us, they know that there's, the actuator's broken. So through the predictive analytics, it's telling them, okay, go change out this other part at the same time. So before the tech's even out there in the morning when they're looking at their work list, they understand that, okay, maybe I'm not certified to go do this second order job, but leave the wing open. The next guy will come in later that day and perform that check. So we don't have to do that in the field. That can be done ahead of time. We're just providing the information they need to the device, when they go out to work in the field.
The real-time supervisor over your shoulder through your glasses isn't going to happen anytime soon.
No, that can't happen, and it's happening now.
I tried to start a small business where we did real time in places, and that's why I asked about the communication.
Well,
But I prepared everything, and I had all the data I needed to basically work on whatever I was working on, and I had to go back to the company, and it's just the problem, any problem I had was in the person who I was communicating with, but, I had people like looking over my shoulder, and I had to describe everything, so this would be actually a lot easier to deal with.
Right.
That's why I was asking which percentage of the use cases you've looked at require real-time communications.
So it depends on where you want to start. And if you want remote mentor, then you obviously need your, and I would, in most of these, if they're set up where they are able to have a senior tech be able to, be called, right? A lot of companies aren't at that level yet, but they need to think through that in terms of their support desk to have those ready. And train those senior techs on, they can literally virtually draw exactly what the tech on the field needs to do. So they're actually seeing that. And if I could have gotten this video to run, you could have seen that in real time where the senior tech is literally drawing for the junior tech what to do, where to connect the wires.
Proof of concept, Chris, take the hardware piece out of it. much is that? I mean, this is so new. I have a client that
Right.
wants to play with this.
Yep.
Your software, how long does it take to get a POC done or started?
Yeah, most of the POCs that we've done are running from the $200,000 to $300,000 range. And most of that work is, we've been working with detailed CAD drawings, to be able to import those, do the art meets compute, where you actually have, do the shading, the rendering, so when you explode that part, it's high quality, high resolution. So a fair amount of that is in that development of the 3D object. Now, once you actually build that, obviously that can be reused for sales and marketing, operations, training. So there is a lot of reuse and thought around your content management of these objects, because they're expensive to build if you're going to use CAD files. And in a lot of cases, you need to do that, but in others, maybe object recognition is enough, and we can pull, we understand what it is, and then we can pull the work steps without having that detailed 3D object.
6 months, 3 months?
Oh, no, in terms of development, 6 to 8 weeks.
Really?
Yep. That's one of the reasons we acquired a company in LA that was doing a lot of Hollywood visual effects work. We wanted that level of quality of creative artists as they look and, literally are taking that, and, part of the business is working on Grimm or CSI, and the other part is making beautiful jet engines and, tractor parts and everything else.
So to what degree are you leveraging other people's dev kits, like the HoloLens dev kit or Euphoria or things like that?
We're leveraging all those. We have our own 3D rendering engine, but we'll do Unity, any of the gaming engines that are out there today. If we don't have a feature functionality we need, that's why we like to have our own. We can build that in without having to worry about their roadmaps. All right, these are early days, but it's exciting. I think it's going to be fun to watch as this IoT and augmented reality start to intersect here and have the machines talk directly to the glass and provide those work instructions as we go forward. So thank you for your time.